Hi, welcome to Dr. Madhava's Logic Academy. We're going to learn today about gravity and how it affects the sun, the earth, and the moon, and how it interacts, how it affects the behavior and the motion of these three objects. So let's open. So let's open our applet. By the way, this is PHET simulation software that we can any of you can actually save it and you can use it as well. Just for simulation, let's get started with simple the Earth and the Moon system. And as we all know, once we start the simulation, we can see that the Moon rotates around the Earth, and there are a few things that you have to notice here. So the moon, while it is rotating around the earth, and let's see, a lot of people don't know this, I think. Let's look at the gravitational force. The force of gravity is always towards the center, right? So if the let me pause and ask a question here. Is this force more or this force more? Is the force exerted by the earth on the moon more or the by the moon on the earth more? In reality, both of them are the same, and that is given by forces G into m1 m2 by r square. So if because of the force that is exerted here, we can observe a circular motion given by the moon, but the moon also exerts some force on the earth, and you can see that the image is slightly wobbling here, and it will be clearer if you see the velocity of the center of the earth. It is actually moving a little bit. So you see, it is the center of the earth is also moving, and the motion of the moon around the earth is the reason why we have the tides. As you can see, there is a high tide and a low tide at different points when the moon rotates around the earth. So now let's look at the path. So the path, let's get rid of the velocity and let's look at the path. No, it won't give any. Okay, the path around the earth for the moon is nearly circular orbit. And let's see how we can understand this whole system when we have. Yeah, and let's get back to the bigger scale when we talk about the earth rotating around the sun. Now, as we can see, the earth rotates around the sun in almost a circular orbit. It's very close to circle. It's elliptical, but very close to circle. And if we want to include the moon as well, can you imagine the path of the moon around the sun? Not around the earth, but around the sun. So the path of the moon is going to be like this. As you can see, the path will make a beautiful design like that as it is moving. And can you predict the velocity? Now let's get rid of the path. Let's look at the velocities. If I ask you to look at the velocities of the earth around the sun, now you can see that this is the velocity vector. The one that is wobbling here is the velocity of the moon. Now as you can see, the velocity vector is changing. So does it mean that the moon doesn't travel with constant velocity around the earth? No, it doesn't. The moon travels with constant velocity around the earth, as we have seen in the previous simulation. However, here we are not taking the earth as stationary object. So with respect to the earth, it is moving in the same speed. But as the earth is moving, now you can see this vector changes in size. That means when the earth is actually traveling, when the moon is also traveling the same direction as the earth, okay, around the sun, then you have a higher velocity vector. Like, let's see that. Yeah, right now you can see the moon and the earth are traveling in the same direction. So you have the addition of vectors, and that's why the velocity of the moon is higher. And you can see, yeah, right there, now you can see the velocity of the moon around the earth is in the negative direction because the moon is here, it's going that way. And the velocity of